Hey everyone, this is Roy Nicewonger again from MotleyPixel.com. I'm ready to do some lens conversions here, specifically on the old Minolta MC and MD lenses. Here are some of the lenses we have here that I'm going to be converting. Okay, the first one I'm going to attempt to convert is the MD Rokkor-X 51.4. Next one I'm going to convert is the MC Rokkor PF 58.14. Then I'm going to go with the MC Rokkor-X PG. This is the 50.14, and then the MC Rokkor-X 35.28, and then finally the MC Rokkor-X 28.28. Okay, so here we are. This is the MD Rokkor-X 51.4, the first lens I intend to convert. And first thing you want to do when you look at any of these lenses to convert, you want to check the overall condition of the lens. This lens is in very good condition. There's no oil on the aperture. The aperture operates smoothly, no fungus, so everything's good to go. I do want to point out some differences between the MD Rokkor-X 50 and the MC. These are both 55mm thread versions. Okay, here's the MC in this hand, and here's the MD. The major difference is the length, and the second difference is the weight. The MC is a lot heavier than this MD. Also, of course, the flange on the back, where the aperture mechanics and everything is considerably different. But we'll get into this later when I decide to convert it. We're going to focus on this one. Okay, now the objective in this conversion is to take this M42 to EOS adapter, simply put it over, mount it with these mounting screws here, and then adjust affinity focus, the infinity focus, to bring the element far enough back to where it will achieve infinity focus. Now to do that, we're going to have to take this mount assembly off here. This top portion here with these screws will come off, this will come off, this silver metal flange part and this black part here. That's all that comes off in that assembly. The M42 adapter still won't go over. We'll have to put this in a lathe, and we'll have to turn the threads and turn about 2mm for a total of 4 diameter to get this to actually fit over. Once this fits over, it'll lay flat on this surface, and it will be approximately 1mm taller than the existing mount, which really is quite a bit and something I don't want to happen. So in order to compensate for that, what I'm going to do is remove this flange. Okay, under this flange there are aperture mechanics. We have to keep that. But if you look closely, I don't know if you can see this or not, this flat surface here steps up and then steps down. I'm going to turn this flat all the way across, so then this piece will lay flat here, just like this, all the way down. Now I have to be careful because I already mic'd this piece, and I only want to take about 1/2 mil off of here, and that should be just fine. I'm going to lay this down, so I'm going to take this piece off and actually use the inside jaws and lay this down flat. I'm also going to take this on this side, and I'm going to lathe this surface here. I'm going to do a facing operation and take about 0.3 mil off of this, and then it should all fit over just fine. After marking the holes, should be able to mount it onto the camera and then adjust infinity focus to bring the element back. Now I've already adjusted infinity focus on this, and there's something I want to show you inside here where we'll have to do a little bit of grinding to achieve infinity focus. So if I focus to infinity right now, here you can see a healthy millimeter plus of rear lens element protruding here. And if you look at the MC at infinity focus, it's not even protruding. The actual rear of the lens element is flush. So I've moved this back already some, which is what I'm going to need to do anyway to achieve infinity focus, because the registry distance for Minolta is 43.5 millimeters, whereas EOS is 44 millimeters. So you need to get that element further back into the mirror box. So let's get on to the disassembly. Okay, here we are. The back main flange with the aperture mechanics is removed. This is where I'm going to grab this piece on the inside jaws, and I'm going to turn this surface right here down about 0.3 mil. Of course, I'm going to do measurements and document too. This mount piece here can be discarded. I'll probably keep it as spare parts. The associated screws that go with it here, of course you want to keep them. You never know when you're going to need screws that size because they're pretty difficult to find. Which brings me to the last point. Whenever I finally mount this on top of here, it's going to add some length, and the screws that came out of here may not be long enough. But don't fear, I found a resource where you can buy 20 at a time, microfasteners.com. These are M16 by 0.35 by whatever length you want. So I bought 25, 24, 23. I got plenty of screws. These are stainless Phillips countersunk flat. So those are good to have. So anyway, back to the point of adjusting infinity and stuff. I've already done a lot of adjustment here to bring this lens element further back or up, in this case, in this position, by adjusting the infinity focus. In order to do that, though, there is a L-shape interlock thing here, and I forgot the name of it. It's called like a stand. I forgot what it's called. Stand something. Well, you've got to take that out, and if you notice here, this looks like it's been grinded. Well, this one goes in reversed of a lot of ones that I've seen normally. This little L part normally goes down inside the groove on the helicoid. This one sticks up, and it was sticking up about 1 millimeter. So I used my Dremel with a cutoff wheel and grinded down 1 millimeter, because as you focus, you see that? That's going to minimum focus distance, and then whenever you go to infinity, it's coming up. It will actually, where it's at now, if it was default, if it was factory, this would be protruding too much, and then the aperture mechanic plate will not go on. So you got to take about 1 millimeter off of this piece right here. Now, adjusting infinity, that's a quick and easy one. Okay, real quick, infinity adjustment is quite easy here. You got to remove the ID ring. This one here is not that difficult. It is a plastic ID ring. It doesn't really have any real easy to see notches, but if you look on the inside here, there's a notch here and notch here. What I end up doing in a lot of cases, even with the aluminum or brass ID rings, I hate burring them up really bad. One thing that you could use is some type of rubber end. I use this fitting here, this PVC fitting, and some drawer grip, the stuff that you put underneath things so it doesn't slide on a surface, so it grips. As long as it doesn't really touch the lens, you're okay, but you can stick it on here, apply pressure, and turn the ID ring. You need to take the ID ring off for infinity focus. It's coming off here. Okay.
Is there any way you can watch the boys while I finish for 20 minutes? Logan wants to swim.
Okay, the ID ring is removed. This is the filter thread baffle, if you will, shroud. You're going to take these screws here out, lift this out, and then what you'll find are screws deeper inside of here. There's usually 3, and basically you're going to loosen all of those and rotate the focus ring independently of the helicoid. And there are documented procedures out there on how to do that, but essentially if you want to get more infinity focus, you want to go to infinity focus. You're at infinity, loosen all 3, you want to back off about 2 or 3 millimeters, tighten 1, and then it will relock with the helicoid, and you're going to go back to infinity, and that's extending it further back. And you're going to keep doing that procedure until you think you're far enough back. And then you're going to want to leave this all off so that when you test on the camera, you have mirror clearance. For example, on a full frame 5D or 5D Mark II, you want to get it to where it just doesn't hit the mirror. Now, I've done a lot of testing with these Minoltas. I've had mirror collisions, and so far I haven't had any damage to both the mirror or the element. It's not a big deal. You just focus back off of infinity, the mirror will drop. You go and you do your adjustment. If you're too far infinity wise, you'll go to minimum focus and do the same thing. Loosen that one that you tightened, move it a little bit clockwise by about 2 millimeters, tighten one, and then you'll go back, and that's actually bringing it further away from infinity focus. Alright, now before you go any further with this aperture mechanics flange here on the lens, what you want to do is you want to look at the distance scale on the diamond, okay, which is located right there. What you want to end up doing is taking a Sharpie marker and marking somewhere, even scribing, you can scribe it if you want, on the flange where that diamond's at. It's going to be right around where the hole is at there. So we have that marked there on the lens. And then what you want to end up doing on the M42 to EOS adapter is mount it to an EOS camera such as this 30D, okay, with the locking pin engaged here. You want to find the 12 o'clock position and you want to mark it. So now the reason why we do this marking on the M42 to EOS adapter and the aperture mechanics flange, which is marked right here, is that way when when we go to mark the holes to drill using this as a template, we line this mark up here with the mark here. We align it and we mark our holes. We use a fine center punch such as this one here, and then we drill our holes. That way when the lens is mounted to the camera, we will have the diamond distance indicator scale facing upward at the 12 o'clock position, so it's like a normal lens. Okay, ready to do my first cut on this lens. We're setting at 3.32 millimeters, 3.32 if you can see that, 332. So I'm going to start shaving that raised area on this aperture flange here. Give it a nice cut here. See how that stock is curling off like that? We don't have any chatter. Okay, this 0.57 millimeters removed. Okay, what I've decided to do now after the facing operation on the flange with the aperture mechanics is to drill out that aperture pin that protrudes up. That's going to be in the way. There it goes. All done. Okay, here I have the M42 to EOS mount chucked up in the outside jaws. So here's the flange with the aperture mechanics. This outside diameter here is 45 millimeters. The inside diameter here is 41.5 millimeters, so that's a difference of 3.5 millimeters. So I need to take off 3.5 millimeters in order for this to fit in like so, and so that this fits flush here. So that's got to fit in. So 3.5 millimeters, that's 1.75 mil here, 1.75 mil here. Okay, the lathe operations are complete, and here I have the M42 to EOS adapter mounted onto the aperture mechanics flange for the Minolta lens. Real quick here, I turn the outside of the M42 to EOS adapter down to 60.6 mil diameter, so it's flush here. That way it's going to sit down on here, and these aperture aperture ring tabs won't get in the way of anything. It should work just fine. Another thing that I had to turn down that I did not film. Okay, I also turned this top part of the bayonet, or the aperture mechanics flange. I turned 0.4 mil. Did a facing turn on that, 0.4 mil. The reason for that is when this goes on, this surface was touching the inside of this flange here, so I had to take 0.4 mil off of that. This is almost complete. All I have to do now is use the aperture mechanics flange as a template to drill the holes, and the holes will be screwed in on the flange here, and I should be good to go. Okay folks, I'm done drilling the holes in the M42 to EOS bayonet mount, and I have to say this is now about 2.5, almost 3 months since the last clip of this video. Took a long break. The last thing I did with this mount in the drill press is I tried to, if you can see here, cut out half of this bayonet lip area because of where the holes came through. That was the most difficult and frustrating part. With various Dremel bits on high RPM in the drill press, and let me just say that this part of the whole process so far has been the most difficult. Getting them to line up with the holes, getting nice smooth cut, even though it's soft material. You really need a mini CNC machine with some good end mill bits. I ended up investing in a $25 5/16 inch end mill. It's a 4-flute design, and it works quite well at 3100 RPM, fastest spinning rate on the drill press. But what I did about 2.5, 3 months ago, I was countersinking these holes with a diamond countersink bit, and I had this mounted in the drill press vise, and I had it mounted on solid steel through the hole. I wasn't paying attention. I went ahead and started to press down to countersink. I met resistance. I wasn't paying attention what was going on. It was hitting the steel underneath the drill press vise, and it broke the bit, walked the bit. The bit walked all over the face of the mount here, put a gouge right in by this hole right here. Really frustrated me to no end. So I threw the adapter to the back of the workbench and called it a day. And here I am 2.5 months, 3 months later, and I decided to go ahead and try to finish this and make this my prototype and first round. And I think I made it work. In order to smooth out these rough gouges, because they were pretty bad, these gouges here and here, I put it back in the lathe, and I've taken some of the nickel plating off just by turning it in the lathe. So it's not ideal. The nickel plating is your friction and wear surface, so you have to be careful. Backside, you can see that I left the bayonet locking pin area here so that the locking pin on the Canon EOS body will still operate. Okay folks, final measurement. On the Minolta mount, this surface right here will be our reference. So from the bottom here to the top of this surface here, the measurement is 2.23 millimeters. From the bottom reference surface here again to the top here is 8.08 millimeters. So take your default stock and determine the delta. For the M42 to EOS, from the bottom here to the top here, which should not be machined, only the bottom, is 1.17 millimeters. The diameter is 60.7 millimeters. The inside diameter here is 44.6 millimeters. And this thickness here, because I did turn some of this surface right here out as well, is 1.2 millimeters. Alright, here it is on the actual lens. Again, this is the Minolta MD Rokkor-X 51.4, 49 millimeter threads on the filter threads here. Everything seems to operate fine. I do have the aperture detent bearing removed for right now, but it looks like I've got plenty of clearance here on this tab, so I don't have to trim it down any. Aperture seems to be working just fine. Canon 30D, and this is a crop sensor, so making sure that there's the red dot is still on the M42 to EOS adapter, so we can line that up. That should line up just fine. We should hear that sliding nice, should hear that click. Yep, and that clicked in just like that. Make sure that this slides. Very nice. And it looks like I'm sitting at infinity there. No mirror collision there. Now, I'm not going to video much anymore on this tutorial. I think I pretty much described in as much detail as possible on how I converted this lens from the Minolta MD mount to Canon. It is a destructive conversion. It is not reversible, but in my eyes, I'm not going to use any type of film body, Minolta body, or even digital SLR. I'm not even sure if Sony Alpha will natively accept these. I think they may. I'm not entirely sure. But the utility now of this lens for me is great because I can use it on my Canon bodies, and I can service the lens. Nothing was epoxied or glued. I'm almost ready to go. What I'm going to have to do now is do infinity focus calibration, and what I will also most likely have to do in this conversion, if you look here, I have the leading bar and the adjustment such that it looks like I have at least, gosh, 1.5 mil protruding here, so that's pretty far back. I might actually have to go a little bit more back on this element depending on the optical formula and how that works. Again, I'm going to do an infinity calibration, and I'm 99% confident that once I lock that in as such, on the 30D, there's maybe a 30% probability that I will have mirror collision on the 30D. On a 5D or 5D Mark II full frame Canon, there's no doubt in my mind, 99.9% probability that the mirror will collide with this rear element group housing. I already have a video on how I achieved infinity focus on the 5D Mark II with the 5814 Rokkor. So the way I do that is I turn this barrel down, which is somewhat tricky, but I do have a video tutorial on how I did that on the metal lathe, and I will have to do that. So that pretty much concludes this conversion. It's been worth my while. I love tinkering. My next conversion will hopefully be the Minolta RF 800 fixed f8 mirror lens. It's a beast. I hope to convert it and try to shoot the moon with it. We're going to see how that works in the next video tutorial. Thank you very much for being patient. I know this has been a very long video tutorial. Please go out to motleypixel.com in the forums, check out the manual focus thread there. I'm starting up some discussions with all of these videos, and I would like to hear your feedback. Please register, join, ask questions. Please send me an email, drop me a note, send me a private message, whatever you want to do. I really enjoy this stuff. So thanks again. Goodbye.